What is real? How do you define real? If you're talking about what you can feel, what you can smell, what you can taste and see, then real is simply electrical signals interpreted by your brain.
Yo guys, how do we know if our universe is a simulation or not? If you can feel something, does that make it real? Well, I mean, the objective answer is no, because as the rubber hand illusion demonstrates, there was no real pain, but yet it was as real as can be for the participants. So, full warning, today's video is purely for thought, only to get you to question things further. I am not an expert in computing or physics or quantum anything, so just keep that in mind. But if you were to ask some people if we were living in a simulation, they might reply, "Does it even matter? Just as a character in a video game can't tell if they're in a simulation, neither can you." But I think this is just wrong. In fact, what if I were to tell you that I thought of a way that we could confirm if we were in a simulation or not? Skeptical? Don't worry, I am too. But follow me. This is Outer Wilds, a great puzzle space game from what I hear. I have yet to find time to play it, but while watching a documentary with the team that made this game, I learned something insane. What you are currently looking at is a trick on your eyes. This simulation is not working like you probably think it is. But before we get into that, I have to show you something. This is a space game prototype that I made in a couple of days. I loved it so much that I was planning on making it an actual full game of some sort. But there was this strange issue that kept occurring and I just couldn't figure out what was going on. So check this out. This here is the home planet, right? And these are faraway alien planets, about 100,000 units away from each other. However, whenever you visit these far off planets, the collisions and movement just got all weird and inaccurate. It's very maddening and so crushing not knowing what to Google search to fix this. But thanks to the documentary, I now know what the issue is. So in the documentary, my mind was blown when they started talking about the same problem that I had but didn't fully understand it, and they actually came up with a very clever solution. They simply just kept their player at the center of the universe at all times. This basically ensures that everything happening around the player is happening at the highest possible resolution. Simple but very brilliant. Oh, what? You don't understand how this solves the issue? Okay, don't worry. Have a seat. Let me explain. You see, there's something called the floating point precision error that occurs when dealing with large numbers. Basically what it is that a computer is just a big old factory that stores zeros and ones. And it combines these zeros and ones in such a way that it can make just about anything you can imagine. From the text that you send to your Tinder date, all the way to your favorite 3D model. However, there's a catch. There's always a catch. This zeros and ones factory has its limits. It can only store so many zeros and ones to make the stuff that you need and enjoy. Now, the actual logic behind this is way more complex than I'm about to explain, but I'm going to simplify this so that you can follow along and understand the issue. So say that any number that can be stored on the computer has a hard limit of 8 digits. So this is what 0 looks like, this is what 2 looks like, 37, 1109, you get the pattern. Well, this also includes the decimal place. So this is what 1.5 looks like, 12.38, 79.12507, and so forth. But the real problem here is, say that you have a number like 100,000. That number alone takes up 6 digits, one more digit for the decimal, and that leaves you with only one space for decimal data. Meaning the 100,000.5 location exists, but the location at 100,000.25 does not exist, nor does the location at 100,000.125. There just isn't enough space to represent this location. And because every 3D model is basically just a bunch of points around a center point, if you have a 3D model with points located at 0, 0.25, 0.5, 0.75, and 1, well, the 0.25 and 0.75 will have to round to its nearest because those locations don't exist at the location 100,000. Look, this is a bit of a headache to try and understand, so have a look at this. Here on the left, we have a planet that's located at 0, 0, 0 in the universe. And here on the right, we have the same exact planet, but located at 1,000,000 in the universe. There is no difference in the rotation or 3D model, but you can see what being far away from the origin point does to the planet. You will end up with a lot less information to represent your data. In essence, ripping it apart and spaghettifying it. And if you're not completely sold yet, here's the same thing happening, but with my 3D modeled head. Some might tell Mr. Stark I don't feel so good. Now, if you're like me, your jaw should be hitting the ground learning this, because I've always thought that rendering engines like Unity that I'm using here was spatially infinite. But I mean, of course, computers have their limits. And so, back to the documentary. The Outer Wild solution was to keep the player centered at 0, 0, 0, and to not move them, but instead move the entire universe to get closer or further away from the center, giving everything closer to the center the most information possible to represent itself. Simple, but pure genius. Which leads us to the other day. For whatever reason, this got me thinking about the Voyager 1 probe. You know, the satellite that launched in 1977 with Carl Sagan's golden disc on it. You know, it's the furthest man-made object from Earth. By this point, it has traveled well over the distance that I was trying to travel in my game. But I'm sure it hasn't reached any floating point errors. I mean, right? Basically, where I'm going with this is that with our computers of today, floating point accuracy starts to fall apart at around 7 digits, which is a surefire sign that you know a computer is dictating whatever you're interacting with. But is it possible to test the limits of our universe and figure out when, where, and if spaghettification happens like this to matter itself? I highly doubt it. With our technology, even into the foreseeable future, it'd be like ants trying to walk a full circle around Earth. Because I mean, our real world universe is able to measure things on the scale of neutrinos, man. Neutrinos, it's tiny. But just as I thought modern rendering engines were infinite, until we can confirm one way or another, I'm gonna hold on to the possibility of this. Because if it were to happen, we would know for certain if we were in a simulation or not. Because all computers have their limits. You can now feel free to take to the comments and tell me how stupid I am for proposing this idea, but also, please subscribe, make sure to follow me on socials, and God bless Fruitless Pizza.